Good morning. In our previous discussion, we have discussed what is solar energy, advantages and disadvantages of PV cells, construction and working of PV cells. So PV cells are made up of silicon. It is usually made up of solar grade silicon. What is this silicon made up of, or how this solar grade silicon is synthesized? We are going to discuss today in our discussion. Solar grade silicon is obtained by two steps. One is manufacture of metallurgical grade silicon. Second step is conversion of metallurgical grade silicon into solar grade silicon. What do you mean by? So these both steps put together is called as union carbide process. So in general, solar grade silicon is synthesized using union carbide process. So before going to this synthesis in depth, what is metallurgical grade silicon? Why it is not used in synthesis of PV cells? We'll discuss. So metallurgical grade silicon, the quartz, whatever is there. So the ore of silicon is taken and it is from that silicon is obtained. Thus obtained silicon is 98% pure and that is called as metallurgical grade silicon. The impurity level of this silicon is very high and it cannot be used for manufacturing photovoltaic cell. And we have other type of silicon is called as semiconductor grade silicon. And then, as the name indicates, that silicon is used only to manufacture semiconductors. So the impurity level in this semiconductor grade silicon is very, very low. Therefore, when this cannot be used to manufacture photovoltaic cells, then which type of silicon can be used? Then what type of impurity level should be there? The impurity level in the silicon should be intermediate between metallurgical grade silicon and semiconductor grade silicon. So such type of silicon is called as solar grade silicon. So today we are going to see the synthesis of solar grade silicon. First, manufacture of solar grade silicon. We are going to take silica in electric arc furnace. We are going to heat it with carbon at very high temperature. It is around 1500 to 2000 degrees Celsius. When we heat it, what will happen? Silica get reduced to silicon, liquid silicon, and carbon monoxide will be emitted. Thus obtained carbon monoxide will escape into the atmosphere. The silica will be fed into the electric arc furnace. This silicon, that is water of silicon is obtained, liquid silicon will be continuously withdrawn from the furnace. Thus obtained liquid silicon may contain impurities such as aluminium or calcium or magnesium. We are supposed to remove these impurities. So removing the impurities such as aluminium, magnesium, calcium is called as refining process. So how to remove? We have aluminium, magnesium, calcium. So this silica will be mixed with, silica will be mixed with this, thus obtained liquid silicon. We're going to heat it. When we heat, if aluminium is present, it will get oxidized to alumina. If magnesium is present, it will get oxidized to magnesium oxide. If calcium is present, it will get oxidized to calcium oxide. It is not necessary all the three should be present. It may sometimes magnesium, aluminium, calcium might be present, or any one will be present. If aluminium is present, it will be removed as alumina. If magnesium is present, it will be removed as magnesium oxide. If calcium is present, it will be removed as calcium oxide. Thus obtained silicon is called as metallurgical grade silicon, which is 98% pure. So as discussed earlier, it cannot be used to synthesize the photovoltaic cells because the input level is high. Now what is the second step? We are supposed to convert the metallurgical grade silicon into solar grade silicon. How to convert? Let us discuss. Thus obtained metallurgical grade silicon is refined. That is, it will be heated with dry HCl, this anhydrous HCl at 300 degrees Celsius to obtain trichlorosilane. What is silane? SiH4 is silane. Since the three hydrogen atoms of silicon is replaced with chlorine atoms, it is called 3 chlorine atoms, it is called as trichlorosilane. So the metallurgical grade silicon is heated at 300 degrees Celsius with anhydrous or dry HCl to obtain trichlorosilane. Thus obtained trichlorosilane is hydrogenated. That is, we are going to subject to hydrogenation or heat in presence of hydrogen at 1000 degrees Celsius to obtain dichlorosilane or trichlorosilane. So thus obtained trichlorosilane will be subjected into quaternary ion exchange resin. So quaternary ion exchange resin. What do you mean by ion exchange resin? So quaternary ammonium ion exchange resin. So this dichlorosilane and trichlorosilane will be sent into quaternary ammonium ion exchange resin, where the chlorine atoms present in the trichloro and dichlorosilane will be exchanged with the ammonium. So if this is the quaternary ion exchange resin, so here hydrogen atoms will be present over here. When you pass the silane over here, the chlorine atoms present in the silane will get exchanged to the hydrogen atoms present over here. So each and every chlorine will get exchanged with the hydrogen atom over here. So once it comes out of this, the entire dichloro and trichloro will be replaced with hydrogen atoms and we get silane. Thus obtained silane may contain impurities. It should be purified. So how it is purified? Usually it is purified by distillation process. So what is distillation? Distillation means you're going to boil it, right? So when you boil the silane, so the impurities will boil first. The boiling point is very high, so impurities will go off. So or what will happen at the boiling point? If it is 1500 degrees Celsius, at 1500 degrees Celsius only silane will boil, right? And later it will be condensed. So whatever condensed silane you get here, it will be pure enough. So our main aim is to get silicon, semiconductor, solar grade silicon. But what did we end up? We ended up in obtaining silane. So what to do? We're going to subject it to a process called as pyrolysis. What is pyrolysis? I think you might have discussed, you might have studied this pyrolysis, or you might have come across about pyrolysis in your +1 or +2. So heating certain substance to a very high temperature wherein the bonds break, maybe an ionic bond or a covalent bond break to give its own different elements is called as pyrolysis. So same thing we are going to use here. We're going to take silane and heat it to very high temperature where we get silicon and hydrogen. So hydrogen will escape into the atmosphere wherein silicon will be in the form of liquid. So thus obtained silicon is called as solar grade silicon. See the image, you can see the solar grade silicon here. The silicon can be used to manufacture or synthesize your photovoltaic cell. If you want to purify it further, it can be purified or refined using zone refining technique. There is a small animated video here to show how to make a chip. So let us see how to make a chip here.
This is the raw material chips are made of. Sand. It is made up of silicon dioxide. Silicon is the second most common element on the Earth's crust and only exists in bonded form. Complicated chemical and physical processes are needed to convert silicon into a crystalline form and make sure the crystals will meet all the requirements necessary for chip production. The final product is a monocrystalline silicon rod of highest purity. This means the rod has only one impurity atom for every 10 million silicon atoms. Silicon is a semiconductor. Its atomic structure looks like this. Each silicon atom has 4 outer electrons. There are no free charge carriers. The pure silicon monocrystal is non-conductive at room temperature. To make it conductive, small quantities of specific impurity atoms such as phosphorus are built in. Phosphorus has 5 outer electrons. The 5th phosphorus electron built into each molecule of the silicon crystal lattice can move freely. Because of this structure, the silicon phosphorus crystal is negatively charged, or N-conductive. Boron atoms, on the other hand, have only 3 outer electrons. When they are built into the silicon lattice, 1 silicon electron is missing. This creates electron holes. They move through the crystal like positively charged electricity particles. The material is positively charged or p-conductive. The transistors in modern memory chips are constructed from p and n conductive layers such as these. Transistors are the smallest control units in the microchips. In the heart of an NMOS transistor, for example, we find p and n conductive layers of silicon crystals. An additional layer consists of silicon oxide and acts as an insulator. A layer of electrically conductive polysilicon is applied on top of it. Every transistor has three connections. The middle one is attached to the gate, the electrically conductive polysilicon. If we apply an electrical charge only to the two outer connections, electricity is unable to flow. The transistor is blocked. Things are different when an additional charge is attached to the middle connection. The electrons from the p layer now wander toward the middle connection and accumulate at the border area between the silicon crystal and the insulation gate oxide. A channel through which the electrons can flow is formed between the islands of n-conductive material. The electrical circuit is closed. The transistor can be switched back and forth between current off and current flow, that is to say, between 0 and 1. This binary system is the basis of electronic data processing.
I think what I've seen how n-type is obtained, p-type is obtained. Surely we'll tell you n-type is rich in electrons, p-type is rich in holes, right? I think now you would have better understood why n-type is called. When we dope phosphorus, why silicon become electron rich. When we dope boron, why it will become hole, it's rich in holes, right? So this is how your silicon is manufactured, PV cells are manufactured. Thank you.